Okay, good morning. Welcome to this session on BI. My name's Russell. I'm with Intergen. I'm the practice lead for the Wellington region. Today we're going to be looking at real-time data insight into retail store and marketing performance. It's becoming more and more essential that retail stores remain relevant to their customers. This can happen for a number of reasons. The way in which people are shopping is changing dramatically. People are now tending to use the high street store as the best way to get the best price that they can. Lots of people are becoming more informed around the products that they're buying, and this is due to the availability of product information over the internet. It's also due to the fact that people have the ability now to shop online wherever they are, mobile devices, smartphones, tablets, on your PC at home. So according to last year's Nielsen report, the number of Kiwis aged 18 and over increased dramatically. In fact, we saw an uplift of 38% on the previous year in terms of people that were buying 11 items or more online. Even for smaller purchases, 6 items or more, this increased 21% over the previous year. It's quite a large chunk of money that's going onto online shopping, and the trend is continuing to grow year on year. So although we're still fairly small at the minute, that 26% is money going overseas. People are able to find products in markets they can't get the goods that they're looking for in New Zealand, or they're able to search down better prices, better information, and get better deals on stock. So it's becoming more and more relevant that people remain up to date with the products that they're selling and what they can offer their customers. So why does relevance matter? Messaging and offers finely tuned to a targeted audience have been and remain to be the keys to effective marketing and therefore effective revenue gathering. The more you can offer a personalised experience to the exact target audience across any of your marketing campaigns, the more likely you'll be able to convert potential customers into actual customers, and therefore the ability to drive revenue increases. Being able to respond in a dynamic and adaptive method as different business solutions come up allows you to retain a high level of relevance to your customers, and it also allows you to address areas in your business where you might have slow periods of the day. So when we're looking at relevance, we've put together a series of components which we'll walk through today to explain how a simple solution using the Microsoft stack can be delivered and deployed to help you address these issues. So walking through the structure of today's session, we're going to look at the problem and some of the key questions that people ask. Why should we be looking at this? Why is it important to my business? Then we'll take a look at the technology that we've actually deployed here. So we're using relatively few components to be able to deploy this solution. And then at the end, we'll take a look at the actual code for the demonstration that we're going to run and show you it in action. So onto the problem. Retail is a highly dynamic and highly diverse environment when you start looking at the information you're gathering. There's information relating to the sales that come through your point of sale systems. There's information that relates to other media, social media, for example. You'll have customers out there, when you offer a product to them on special, they'll buy it because of the price, potentially. They'll then go away and they might blog about it, they might review the product on YouTube. It's becoming more and more common now. And you want to make sure that the products you're selling reflect well on your store. So how do you harvest this additional information into the business? Mobile devices we've already touched on. They're becoming more and more crucial. People are shopping on the move. People are able to scan QR codes from advertisements to get promotions, to get special offers on products. There's RFIDs or RFID tags now embedded in the barcodes. this is becoming a lot more crucial to stores that are deploying promotions in store. For example, supermarkets often run these sampling exercises. They'll invite an organisation into the supermarket with a stall or a promotion booth to trial the success of the product, how many people are interested in that product, and therefore how many people go through to the shelf, buy it, and that goes into sales figures. By accurately measuring the RFIDs as they go through the barcode scanners at the tills, for example, you can start to ascertain in real time from all those transactions where the most successful place in the store to put that promotion stand is. Not where the product is on the shelf, but how and where in your store you target people to get them interested in the product. By looking at this in real time, you can start to see if you put a particular promotion in one area of the store, maybe not a lot of people go there, or it's where people go for household commodities, milk, etc. So they're focused on getting one thing. If you move it to a wider area, bigger aisle space, near the doors, near the checkouts, where people are browsing all the goods at the storefront, there's more chance that those people will become interested in the product, and you might see the lift in sales from your promotion. And the last thing is your geographic area. There's a lot goes on in a single area. If you imagine that you own multiple stores in a given district, you might be interested in the performance store by store. So you also have the ability to limit the geographic range for the information that you're harvesting. So this allows you to see how loyal your customers are. If another store offers a promotion but it's further away, do people tend to move over to those stores? You might also want to find out the draw for your store. How wide a catchment area can you develop to pull people into your store? So all of these are very relevant pieces of information when it comes to sales and marketing. So this data in itself isn't too complex. Things happen over time, we can monitor them, we can collect them in a relational database. The real key to this is the complexity being derived from all of these scenarios happening at once. They all follow the same timeline, but the sale of a product might come 3 hours before that same person for that same product reviews it on a social media forum. So how do you correlate the results? And this is what makes complex event processing very useful to this type of scenario. The goal of complex event processing is to identify meaningful events, collate them from the different sources into one aggregated information store, and to respond to them quickly. So how can you make sense of complex event data? Well, Stream Insight is what we're going to demonstrate today to show you how to do this. Stream Insight allows you to develop predefined queries, listen to streams of data, so live streams of data over time for components that meet the criteria you've established, and then collect and harvest that data within a given time period and process it for your business benefit. So let's take a look at the technology that we've used for this solution. As we can see, it's a fairly simple technological stack. We're only really using 3 components here. We've got Stream Insight, which is the engine that we're going to use to collect and harvest the information. We've got the SQL Server backend, which is going to be our data store. And in this example that we're going to be demonstrating later, it's also going to be the source provider. Now, sources can actually come from anywhere, as we'll touch on later. And then at the end, we've got the BI platform. How do we actually visualize this data to make it easier for the company or the business to ingest, to actually make informed decisions about it, analyze it, and move forward? And the ring around the outside effectively represents the different phases of the process that you undertake as you go through this hardware stack, software stack. And this tends to be a virtuous cycle, and we'll discuss this a bit later as well. So on to Stream Insight itself. So has anybody here touched Stream Insight before? Have any of you used Stream Insight? No. It's a relatively underutilised stack. I'm not aware of many people in New Zealand having been using it. It's a very capable engine for processing this type of data. So some of the key points about Stream Insight. It's real-time information processing. So we're not talking about the same processes that you'd follow in a SQL Server relational database environment, for example. If we take a hypothetical of counting cars through a car park, in your relational database example, you'd follow the structure of, I want to count all the red cars in the car park over the course of an hour. So you'd fill up the car park, you'd wait an hour, you'd stop people entering the car park, and then you go through and count all the red cars. And then when you've got that result, you can then move on to the next query. Effectively, what we're allowing Stream Insight to do is to go through and sniff all these data feeds in real time. We're not actually storing the information anywhere using Stream Insight. It's just looking out for some of the key metrics that we've put into the queries. So for our real-time information processing, we don't have to stop and start the flow of traffic in and out of the car park anymore. We can let cars come and go as they please, and Stream Insight's just telling us for a fixed window within an hour how many red cars have entered the car park. Now this obviously has great benefits. We're not having in a large database to wait for data refreshes, to sync our data overnight, or to reprocess our cubes or analysis services information. The second great piece of functionality about Stream Insight is that it gives us continuous insight. Because we don't have that lag period, we can just keep listening for information. We can output that data to any format we want through the extensible framework that Stream Insight offers. We can also start to process what we're seeing in real time against our historic data environment. So rather than just be reliant on what's coming down the pipe at this given moment in time, we can also start to correlate these patterns that we see for a certain period of the day, for a certain week, for a certain time of the year, against our historic data information. So we have the ability to combine that historic data from our databases to the Stream Insight information, and we can start to mine our database actively. So over the course of the day, if we have bad weather, the more people drive to work. So we can start to correlate this information. We'll see more red cars in the car park, no doubt. And we can start to monitor and manage KPIs. So an event might be triggered on being able to process information once it's reached a certain threshold. One of the other examples that Intergen are working on, as you may have seen from the keynote speech, is a product called Signal. And Signal harvests social media feeds for the emergency services and other emergency response groups to analyse, to start to identify where patterns are coming out in public, and so they can respond to those events in a timely fashion. Signal's taking in multiple data feeds from multiple social media providers. And we might want to say, if we get 10 results of a shooting in a particular suburb across social media, for example, it's of interest to the police. However, if they come across 10 years, may not be so relevant. If Stream Insight can tell us that we've had those 10 reports within a single suburb in the course of an hour, then it's probably something we want to flag. So we've used Stream Insight, or we're looking at using Stream Insight to start to monitor and manage these kind of threshold events. And this can be used to flag alerts to police. It can be used to flag other work stream events further down the chain. So it might cause a patrol car to be dispatched if they get the right information to the right area of the system in time. Simple integration. So Stream Insight has an extensible framework. It's written in C#.NET. And this allows people to build and generate adapters, either input adapters or output adapters. Stream Insight by itself doesn't have any of these components readily available. There are some core ones that interface with common systems, But the framework has been designed so it can be easily extended and written to support any application you have in your organisation, or to be able to listen to any types of sensors that are out there on the market where you might be harvesting data and information from. And because it's a familiar framework and programming language, you have the ability to reduce your development costs. You're not actually having to get anybody in with any specialist skills to be able to develop this program, to be able to interface with these devices. And it processes large volumes of data. So looking at the retail sector, as we've chosen to do in this example, we're talking probably the lower end of what Stream Insight's capable of. You're probably going to generate somewhere in the region of tens of thousands of records over the course of a day for a store. Stream Insight can be used across the manufacturing industries or across the utilities industries, and they can be looking at generating anywhere up to in excess of hundreds of thousands of events a second. And Stream Insight is designed to sit in your environment and be able to deal with that volume of data. So this is the application and the layout of how Stream Insight actually works. So on the left-hand side there we have a series of event sources. Now sources, as I mentioned before, can actually come from anything. The example we're going to touch on today will be the AX POS terminals that we're using in our hypothetical example. We can take information from devices such as mobile phones, PDAs, if you've got a workforce out in the field. It can also come from sensors. So if you're listening to a utilities network and you have sensors in a cabinet, for example, monitoring where faults might appear on your network, you can also harvest that information. Web servers, event stores and databases, and this is the example we'll look at. So as all of this information comes in, it gets input through an adapter. So we've developed something to listen to the stream of information coming down the track. And from there, we identify our events. So an event is essentially anything that changes from one state to another. We might want to count it within a given time period. When we've created our events and we know what we're looking for, we can then start to process a series of queries inside Stream Insight's complex event processing engine. So the queries are designed and written in LINQ. And the great thing about this is it's essentially slowing information down to the user. So we're now giving the user more information in an aggregated format that they stand more chance of understanding and processing. It wouldn't be much good trying to fire through to somebody on a desktop, hundreds of thousands of items of data a second. They stand absolutely no chance of reading it. But if we can start to identify what the business needs and the requirements are around what the analyst is looking at, we can write a series of queries to aggregate and count the information over a period of time. So going back to our cars example, one of our queries might be to listen to the stream of all the cars going through a toll booth. So you might have 15 different toll booths, but we're only interested in cars that are coming from, say, Washington State. They have to be blue, and we're interested in how many pass through the toll booths in, say, an hour. So what our queries in the middle in the blue box are actually going to do for us is listen to all the streams of information coming in from the various adapters. In that case, it's the toll booth screens. They'll start to aggregate that information up. So they start counting at 1, and it will go on for 60 minutes. And they're counting all the information for cars that are blue and coming from Washington State. They group all of these together, and all we receive at the output at the end of the 60 minutes is a count value. So we've taken all of that information and we've made it easy to digest for those people. Now, standing queries can be linked together to get more information into your data and to make it more relevant for the types of applications you're actually trying to achieve. And we'll touch on some of these chained examples. Once we have our series of input events and data boiled down through our queries, we actually end up with a couple of events that we're interested in coming out the other side. And again, we can use the extensible framework inside Stream Insight to publish output adapters. And output adapters can be used for monitoring and alerting. They can be used for dashboards in the application of stocks and finances. They could go to trading stations. Or you can actually harvest this information back into your SQL database to use it for future data mining. So what's the typical deployment of a Stream Insight solution? So depending on the size of the organisation or the size of the application you're actually using this for, it will vary. This diagram here represents the general structure for a Stream Insight deployment. Again, on the outside on the blue ring, we've got multiple devices or input feeds. These can come from any of the sources we've mentioned. And what Stream Insight's processing engine will do here is essentially filter out from the vast amounts of information you're collecting the basic information that you need to be able to perform your analysis. So this will be device by device potentially, or server by server, or in the case of retail, we're using store by store. So we're harvesting down all the information that comes through a transaction and saying we're only interested in these core parts of this data. And I don't want to listen to anything else. The next phase is to aggregate it and correlate it. So if we have multiple stores in the region and I'm the regional manager, I don't necessarily want to get all this raw information feed by feed, terminal by terminal from each individual store. It's not very useful for me for making decisions. So we might correlate that up. So we take all of the transactions terminal by terminal, and we can correlate it into one feed for a store. Again, we can use the processing, aggregation and querying capability to refine and tune the metrics that we're interested in listening to. And then the final stage is for historical data analysis, complex analytics and data mining. So this is taking the information from all of our feeds and relating it back to our data warehouse in the head office and being able to say, what events have happened over the course of today that I can recognise in my data previously to now, and start to say, is there a correlation between external events that have happened and what I've seen in my historic data before? Therefore, can I start to plan for new events in the future? Another application that's particularly in the retail space is for businesses to remain highly adaptive to customer needs or the amount of business that they're receiving at any one time. So you might own a coffee shop, for example. You count the number of transactions per hour. You know how many coffees a day you need to sell to stay on target to meet your profit. If you start to run into a slow spot and you've been able to aggregate up the number of coffees sold by type and count them over the course of the hour, you might then have the ability to quickly and easily adapt to put out a message. So Stream Insight's event processing engine could be pre-programmed to do this. If you fail to meet the KPI that you've set for yourself, selling X number of a particular type of coffee an hour, and you hit mid-afternoon and it's a slow period, once that threshold's been reached in the Stream Insight and you drop below it, you might then send out a text message, for example, to all your loyalty club members saying the next 50 people through the door receive 50% off a coffee. Your 50 transactions come back through the till. The system's aware of what it's looking for because we can program the special into the system, so it's now listening for a promotional event. And when 50 people have hit that transaction item, you can stop the promotion automatically as well because you've lifted your level of business up to the required levels to meet your profit for the day. So it's allowing people to be highly dynamic. There's actually a very good example of this by a company called VMob operating over in Europe. VMob are taking information and they're working with McDonald's restaurants chains over in Europe. And if McDonald's are actually going through a slow period in their business, they know which type of burgers have been most successfully selling through the course of the day, and they will actually offer messages by text for people walking past the store. Next X number of customers in receive a discount on the purchase. So Stream Insight's based to sit over SQL Server, and we've used SQL Server 2012 for this example because it provides lots of great capabilities to help support this environment. As the database, it allows us to integrate our analytics through our data warehouse with our real-time operations. We can start to merge these two streams. We can write them out to different tables and then start to combine them in the back end. We can deploy column store indexing to increase in-memory components. Now, there are drawbacks to using this solution. If you implement column store indexing over a table, it becomes read-only. You can't write to that data table at the same time. So the example that you use this in is if you have a large amount of transactional data for your stores in the back end and it's in your data warehouse, it's not so much of a problem. We only want to query it and pull it out. By implementing the column stores, we're reducing the amount of query and processor requirements to harvest that data from our queries. So if you take first name, middle name, last name, for example, and you go on your traditional row-based indexing, it has to write a query to analyse the whole row and then just pull back last name if that's all we're interested in. In column store indexing, we can just say last name and it looks down the column. There's a greater level of redundancy because you'll have multiple last names, so we only want to count the ones that we're interested in, and so we can compress the data a lot more. And this makes it much better for in-memory, faster processing analytics. It's particularly useful if you are wanting to do the retrospective data mining across your database. SQL Server also gives us the built-in capability to do geospatial analysis. So has anybody here actually used geospatial in SQL Server before? Yep. So any examples of what you're using it for?
In application of product to dairy pasture.
Yep. Yep. So working out how much product you ship to a particular pasture?
Yeah, we've done it.
Yep. That's a very good example that more and more people are starting to look at. How do they distribute goods and services to different areas of the country? One thing that I can recommend is that more and more spatial data is becoming available. If you start to want to look into this area, there's lots of free information out there. So you can go to the likes of lins.gov.nz. They'll provide you all information relating to legal land titles. You can also go to Statistics New Zealand, and this is particularly relevant to the retail space. We can get a vast amount of data from Statistics New Zealand. It's all free, and it all maps back to spatial polygons. So if you imagine that you're a retail store and you're looking at your customer base or your loyalty card members, you have their address information on file. You can see where they live, and there are other information sets out there relating to electronic economic spend. So we can start to see areas grouped very similar to what you see on the screen by mesh block, which is a statistical unit. And we can work out how much credit card spend per mesh block has been on electronic goods or on petrol or on groceries. So as a retailer, this is great because it lets me know from the products I'm selling and the areas that I'm selling them into, potentially what portion of the market I'm actually touching. If I can look at economics data displayed spatially and compare it to the distribution of my customers, my total sale for a given suburb might be $100,000 for electronics. I could look at the economics data and the stats data, and I could start to say, well, total spend in that suburb is $300,000. I therefore only address roughly a third of consumer spend in that particular suburb. When you combine it with demographic data or socioeconomic data from stats, you can then start to take this another step further again. Without too much effort at all, using queries inside SQL Server, you can start to say, what is the population within that suburb? How are they made up? What's the average household size? Are they young families? Do they have high disposable income? So if you're not doing it already, I recommend going along to a couple of those sites and having a look at the types of information you can get and how you can use them. And the other great thing is it provides us a common platform. So everything that we're showing today and talking about today has come through Stream Insight or SQL Server or the BI tools referencing SQL Server. So we've got one unified platform. And then the BI model itself. So today we're actually going to be looking at tabular models. We're going to be using Power View to display this information. But there's nothing now stopping you with Microsoft's enhancements to Power View to be able to use your OLAP models in the back end. Tabular is good for this because we have in-memory processing, and the amounts of data that we're dealing with, because we're aggregating all the information up over our transactions, we're actually not processing a huge amount of data. So by doing it in memory, we can do it very quickly and very efficiently. Direct query capability. So if we go back to the example where we're combining our real-time insight with our historic data environment from our data warehouse, some of those queries we might want to run may be too big to hold in memory. So we can directly query the data warehouse in the back end, so we're not having to pull all of that information into memory and slow the process down. And the other good thing is there's a hybrid function between the two. So you can keep the components that you're interested in or query a lot in memory, and then the other data sets which are too big, which you may want to query in the back end, you can do through direct query capability. So this is an example of a tabular model that we've built for this example. And then the last component is the multi-interface publication. Because we're using the Microsoft stack, we can start to show hotspots, for example, where our consumer trend patterns are. Where do we actually sell the most products to? This might also be a map for where do you receive the most positive social feedback through social media channels. It can also be published to SharePoint. You can create SSRS reports. You can create dashboards through Power View. So then the virtuous cycle that we talked about earlier, how does this play a part? Well, by leveraging these three core technologies, we have the ability to focus on the four elements of the ring that you see on the outside. We can automate the information that we're harvesting. We don't have to have somebody script a new process every time we want to run a query. We can leave standing queries in the engine, and it's constantly listening. We can observe and monitor what comes in, and we can harvest that information down into SQL Server. And then we can start to assess and analyze it using the SQL Server and Microsoft BI suites. And once we understand what's going on, we can then start to ask ourselves the questions of what do we need to focus on, what do we need to change, what do we need to improve. If that's all fine and well, and we've got a very clear understanding of what's going on, we can leave this cycle to run. Alternatively, we can pull something out and act on it. So we could start to do a promotion, or we could start to run discounts for certain goods. So the solution that we've put together for today, we're just going to step through an example that we've built for this session. This is essentially taking the example of a series of stores that we've created across New Zealand, and we're listening in effect to the AX POS terminal transactions. So the information that we're getting through these terminals is randomized for the purposes of this. It gives us the control to spin up and pull down specials, turn on and off events as we see fit. So the code that we're seeing on screen here is the code that we have for the manager console inside our Stream Insight queries. So the first thing we're doing with these couple of lines of code is essentially developing the streams. What data sources do we want to listen to, and how often should we get that information? Once we have the streams coming through, we're starting to say we want to write some queries to get all of the raw information, group it together, aggregate it, and push it out into a meaningful context. So you can see this query here is starting to go through and group transactions by store, by category, if we're running a special, which FPOS terminal it came from, and how many have occurred within the time frame that we're monitoring. Now, for the purposes of this example, we're actually going to speed things up. Trying to watch retail data live wouldn't be that interesting for a demo over a matter of minutes. So we are creating transactions fairly quickly, and we're harvesting all of those transactions together on a 30-second basis. And we're going to be saying, for each 30 seconds, tell me what has occurred in those 30 seconds. When 30 seconds is up, stop the clock and start counting again, so that we can see what happens over the course of time. If you're doing this in a real-life example, it might be over a course of hours. So you break your day up into chunks, or you break your day up into shifts, for example, for people on store, so you can start to get staff performance management. Okay, so the next step is to start to build up our stream queries. What do we want to measure and how do we want to measure it? So there's 3 concepts for time analysis inside Stream Insight. We have our hopping window, which moves over the stream for a fixed period of time since the last report. So in this example, this is what we're doing. For every 30 seconds total, what's happened in those 30 seconds. There's a tumbling window, which gives us a rolling total. So for every 10-minute interval, as we've got here, show me the results for the last 30 minutes. So you're going to see a rolling increment dropping off the last 20 minutes from the previous session. And then a snapshot window, which is determined by the start and the end times of the input events. So some of the code here that you can see, we're grouping the queries by store, special and counts, and putting them into our hopping window span. So you can see in here we've got the group statement. We're also telling it what type of window we want to look at and the time frame that we'll be monitoring. When we've got all of that information and we've been listening to the stream, we're essentially turning it into a collection of points. So we have a point event that tells us when that particular instance took place. So we're saying that we've got a sale, a transaction at one point in time, that's an event, collect them for the 30 seconds. You can also have interval events, so going back to the car at the toll booth, you might have the time starting the event when it triggers the pressure pad, to the time at the end when the barrier goes up and the car drives through. So this might be telling you how long does it take somebody to fish around for the right type of change, give it to the attendant, put it in the collection bucket and then move through the toll booth. And then you might have an edge event, and this is where you only know the start time. So an event monitoring process is triggered when something starts, and it might be on a production line you want to monitor when the same component goes out the other end. Now, you don't know when that's going to happen because the line might break down, the component gets pulled off for inspection, but you still want to count every component going through the system. So it will only be triggered when that component reaches the end. Okay. So what we'll do now is we'll start up the console. And we'll start up the randomizer. So this randomizer is essentially going through now using the AX databases that we've mocked up for each of the POS terminals and looking at all of the transactions that are happening within those stores by terminal, and it's just rolling through them. This window is essentially highlighting the 6 queries that we've written in Stream Insight to collate and harvest this information together. Okay. And it's starting to run through. Now what we're doing inside this, and we'll see when it starts to aggregate the information up in the 30-second blocks, is that we're collating the information shown row by row and by the continuous feed on the background screen here. And you can see that we're actually aggregating it up into the different categories. So if I just pause this, you can see we've got category defined, we've got the staff member defined that sold it, we have their ID, we've got a count of how many items they've sold within that 30 seconds, sorry. So we know that the time that transaction's happened, and we can see that this particular set of staff members have sold 2 products, and then the person at the bottom has actually sold 6 products. So this is now running through every 30 seconds and saying, collect me all the information according to the queries and categories that we had at the start of that window. In this instance, we're writing it out to a SQL database rather than pushing it onto another event or another output device, such as an alerting mechanism or KPI mechanism. So you can see here I have my Stream Insights results database, and I've got the different tables relating to the different queries that we've established. So we can see store performance results, for example. And if we run this query, we can now see that this information has started to populate in the aggregated formats inside our SQL database tables. This is useful, as we've mentioned, for being able to go back and use this information for historic data mining. Now, the last component that we're doing for the real-time analysis, if somebody's interested, say, as a regional store manager, I'm interested in all the stores that I have in Auckland, for example, we can start to pull this information through near real time into the Excel Power View application automatically. Now, we're limiting this to a minute's feed because it's the most granular the out-of-the-box offering allows you to go. By being able to code this on the back end, however, you could actually make this more frequent. You can poll the information being written into your back-end database more frequently. But you'll see as we go through, you'll notice the graphs change, the pie charts change, and the scatter plot changes. And this will happen once every minute, so I'll just leave this running for a while so you can see it occurring. Now, this gives the analysis or the regional manager the capability on the fly to see how a particular store is performing, where their particular products are coming from, or where their customers are coming from at any given point of the day, because this is also important for them. If you're going to set up a new store in a particular location, are you going to get more information, more customers through the door during lunchtime and business hours? Or is it going to be a location where you're going to see transient customers on the way home from work? Or is it going to be something that they're only going to go and shop out at the weekend, say an out-of-town retail park? So looking at this dashboard that we've built up here, we can see salesperson and store performance. So the chart that's building on the top left corner here is essentially looking at the revenue being generated over time by store. So we're taking all of these individual transactions which are running in the background, and we can aggregate those up to a store level, and that's happening through our Stream Insight queries. So we're only dealing now with a very small subset of what could potentially be a vast volume of data. The bottom left chart is analysing the number of items sold by salesperson and the average sale price. So we can start to identify if a particular sales member is having an outstanding day. Are they working harder than somebody else? So we can see as the chart's just updated itself, Macy down here has actually been doing incredibly well. They've sold so far, and we've sped up the time, so it's a bit exaggerated, but in the last few minutes, they've actually sold in excess of 200 items, and the average sale price has been $1,200. Compare that to Fabricia down here, who's sold very few items at low revenue. Now, this starts to tell you other things about your business, because if we know what category of product this relates to and what till it was in the store, do we notice that certain staff members are doing better because they're located in a particular area of the store, where there are lots of low revenue, high volume transactions, or is somebody having to sell fewer amounts of large ticket items like TVs? The map is actually showing us our distribution of customers and where they're coming from. So we can start to identify where customers for a particular store are shopping. So we can start to see outliers here. We're looking at our Auckland store and we're starting to get people outside of the CBD shopping at the Auckland store, whereas most of our customers are actually distributed up around the North Shore and the central city areas. So this starts to tell you, why are people moving to the store? Is there a product that they can't get at the other stores? Was the Auckland store running a special and that enabled them to, or caused them to move to Auckland store, buy the item and go home? This chart's actually on specials, so we'll touch on that in a minute. We can also see the total sales by suburb, so we know which suburbs are better performing when it comes to buying the products. And again, because we're actually displaying all of this information in near real time inside PowerView, we still have all the capabilities of the PowerView interface. So we can start to filter by store. So we can say, just show me the salespeople performance and the store performance for the Takapuna store. Now, out of all the products I'm selling, what are the best performing suburbs for me? So in this case, we'd probably say it's going to be Takapuna itself, which wouldn't be surprising because it's where most of our customers are based and it's the locality of the store. But we can also see that Glenfield is also doing well. Most of the sales coming from Glenfield are actually generated by the Takapuna store. So we can start to analyse our business data, our customer base, how they behave in near real time. We can start to look at a particular salesperson or product. So we might want to filter by the Auckland store. We can see our 4 Auckland staff members and how they're performing in the bottom left corner. And we can see the total revenue generated by the Auckland store for each 30 seconds in this case. So we can start to identify that over the last few minutes, revenue is actually tailing off. We're not seeing as many customers coming into the store. We're not making as many sales. So we can also start to filter by staff members. So Aaron C hasn't actually sold anything. Neither has Adam. Okay. And again, the distribution of revenue for the suburb. So we can start to see where the total sales have come from and how they relate to the staff members. So let's look at this in the context of a special. We noticed that the cycle helmets, for example, can be an example we'll take. And we can look at the sales of helmets. So we're now filtering all of our store outputs by the helmets category. So we might want to introduce a special to this. So what I've done now is gone into the system for the simulated environment and we've started to create a special on helmet sales. We'll just give the system a minute to refresh and collect the latest data. And with any luck, what we should see at the bottom is the proportion of sales now to our loyalty customers which are relating to the special on helmets. So we'll be able to start seeing which customers have actually taken up the special that we've emailed to them, text messaged them with. So there we go. That's taken the first sample reading of our specials. So they've they've come through. So we can actually see that when we look across all stores, despite having rolled out the special on helmets for all stores, New Lynn doesn't actually have any customers taking up the special. We can also see that 20% of the Auckland transactions relating to the sales of helmets were ones that were redeemed under the special offer price. And because all the information is related to each other through the tabular model that we've built in the back end, we might want to drill down into those customers taking up the special offers on helmets. So we can see now, just for this 20% of special offers, where the most specials were redeemed from the data that we've harvested. And we can also start to look at the revenue and how that will trend over time. If we left this running for long enough, we'd actually see that due to the increased promotion or the increased activity around the helmets, the chart on the left-hand side of the screen will actually start trending upwards again because people are more interested in buying items on special. So, just to summarise what we've covered, Stream Insight gives you a phenomenal capability to harvest vast amounts of near real-time data to be able to implement in a moderated fashion for your business, your BI analysts, your data analysts, as well as your long-term data mining. It allows you to gain more insight into your company investments, and when you start to combine this with some of the other functionality from SQL Server, such as the geospatial capability, you can start to look outside of your organisation to get a much better understanding of your customer base, how they behave, and how you can become more relevant to them. So in terms of other related content today, there's different examples around TechEd that are quite interesting and related to the information that we've presented here. Data mining is obviously key. The BI Power Hour, which is showcasing more of the front-end tools such as Power View, and the ability, as we've touched on now, that Power View can also take on both tabular models and DAX languages as well as OLAP. You can find me later at the Intergen exhibitor stand downstairs. If you have any more questions, please feel free to come and ask. And again, please evaluate the sessions. The more sessions you evaluate, the greater the chances are that you have winning prizes, and we're always keen to get your feedback. And if anybody's interested, the references for any of the images, the links, and the solutions that we've talked about are included in the reference deck. I believe the slides are being made available to delegates and participants at the end after the conference, so they'll all be in there if you want to go and read more. Thank you very much for your time.